Hey everyone, and welcome. Today we're looking at a Leetcode problem called Zero Array Transformation I. It sounds a bit fancy, but don't worry, we'll break it down step by step and make it super clear. The goal is to see if we can turn a list of numbers into all zeros using a set of allowed operations. Let's dive in. Alright, so here's the problem itself. We're given a list of numbers, let's call it, and we also get a list of CPICs. Each query is basically a pair of numbers, a start position and an end position, defining a range within our list. Now, for every query, we can choose some numbers within its range, or all of them, it's our choice, and subtract one from them. We have to do this for all the queries, one after another. The big question is, after we've processed all these queries, is it possible to end up with a list where every single number has become zero? If yes, we say true, otherwise false. The numbers in start non-negative, so they can't go below zero in terms of what we need to achieve. Let's walk through a simple example. Imagine our list is 1, 0, 1, and we have just one query. It covers the range from index 0 to index 2. So the number at index 0 is 1. It needs one decrement to become 0. The number at index 1 is 0. It's already good, needs 0 decrements. The number at index 2 is 1. It also needs one decrement. Our query covers all these positions. This means this single query can be used to knock 1 off the number at index 0. And it can also be used to knock 1 off the number at index 2. Since that's exactly what they need, we can make them all 0. So the answer here is true. Okay, so what's our first thought? For each number in our list, say at position it needs to be decremented nums at I times, right, to make it 0. Now each query lets us decrement numbers in a certain range. So for a specific number nums we need to make sure it's covered by enough queries to bring it down to 0. If we just loop through nums and for each nums we then loop through all queries to see if they cover I and use them up, that might get complicated and slow, especially if there are many numbers and many queries. We need a way to efficiently count how many decrement opportunities each position gets from all the queries combined. So how can we do this efficiently? There's a neat trick called the difference array technique. Imagine we have a helper list. Let's call it the delta array. When a query comes in, say it covers from 2 for left and right boundaries, it means that starting at index, there's one more way we can perform a decrement. And, just after index, that particular way of decrementing is no longer active. So we can mark these changes. Add 1 at index in our decrement array, and subtract 1 at index r plus 1. Once we've done this for all the queries, our delta array holds all these start and end markers. Now how do we find out the total number of distinct queries covering any specific index? We can do what's called a prefix sum on the delta array. We just walk through it, keeping a running total. This running total at any position will tell us exactly how many queries are active and covering that spot. Let's call this the total operations available at index. So now for each position in our original list we know two things: the value nums that needs to become 0, and the total operations available at that we just calculated. The check is simple. If the number nums is bigger than the total operations available for it, well, we don't have enough ways to decrement it to 0. So the whole task is impossible, and we can stop and say false. If we go through all the numbers in CPICs, and this condition never fails, it means we can zero out every number. So the answer is true. Alright, here's the Python code that puts this idea into action. It might look like a bit at first glance, but no worries. We'll go through it piece by piece. The main parts are setting up that delta array, filling it based on the queries, and then calculating the actual operation counts to check against our list. First up, we get the length of our main list, and let's call that. Then, we create our helper list, the delta array. We make it n+1 in size, so it's a little bit longer than. This extra spot is useful for marking when a query's influence ends. We fill it with zeros to start. Next, we loop through each. Remember, each query gives us a left val and a right val, which are the start and end positions of its range. For the left val position in our delta array, we add 1. This signifies that an operation type becomes active here. Then, for the position that is 1 beyond the right val, we subtract 1 from the delta array. This marks where that operation type is no longer active. We just need to be careful that this right val plus 1 position is actually within the bounds of our delta array. Finally, we figure out the total operations for each spot and do our check. We'll use a variable called current operations, starting it at 0. We then loop from index 0 up to which is the length of our list. Inside the loop, for each position we add the value from our delta array at that same position to current operations. This quote current operations now holds the total number of queries covering the element of is quote calyx. Then comes the crucial check. Is this quote current operations count less than the actual value in at position? If it is, we don't have enough power to zero out this number, so we immediately say false and we're done. If we make it all the way through this loop without returning false, it means every number can be zeroed out. So we return true. So how efficient is this approach? It's pretty good. For time, we iterate through the once to build the delta array. That's about steps. Where is the number of queries? Then we iterate through the delta array, or effectively once to calculate prefix sums and check. That's about steps. Where is the length of the list? So the total time is roughly order n plus m. This is great. For space we use that delta array, which is about the size of, so the space complexity is order n. So, to wrap things up, the core of this problem was figuring out if we could turn all numbers in a list to zero, using a series of operations that affect ranges. The key idea was using the difference array technique. This let us efficiently count, for every position in our list, how many queries actually cover it. Once we had that count, it was a simple comparison. Is the number at a position greater than the number of ways we can decrement it? If so, it's a no-go. Otherwise, we keep checking. This method is much faster than trying to simulate everything directly. Hope that explanation made sense and helped you understand the problem and the solution. If it did, feel free to hit that like button, subscribe for more Leetcode breakdowns, or drop a comment if you have any questions or other ways to solve it. And hey, if you're feeling extra generous, there's always the Boba Fund. Keep practicing, keep coding, and I'll catch you in the next one.